So, I'm going to explain a bit about what Code Mastery is. And Code Mastery started as an idea that me and a few friends had about around this idea. So, I came across this study that said that 70% of IT projects actually fail. And I was like, that's strange. So something I wanted to make an impact in is that we actually start to change that as a community of software developers and IT professionals. And one way that I thought we might be able to fix that is if we actually create more speakers in and around IT. So this idea is to get technology geniuses or programmers who are really good at what they do and IT professionals who are really good at what they do to start giving talks and start practicing their public speaking. So that's what Code Mastery is mostly about. It's also going to look at creating a community of support, projects, and possibly mentors for other developers and IT professionals. And also finding great speakers who are already great speakers to grow our community and educate people more. So who am I? I'm a developer team lead at a company called World First. I've been programming for about 25 years, since I was 6 years old, and working in IT for about 12 years. I'm passionate about helping people. Many of the people in this room who know me have at some point seen me passionately trying to help someone, I'm sure. So, now we're getting into our talk, which is clean architecture and TDD. This is just an introduction, so be gentle. So hands up, who does TDD? Oh, quite a few people, nice. And who has used a layered architecture before? Okay, ooh, tough crowd. So, why TDD? If you write a test for production code, you get the following advantages. You get good code coverage, you get to think about how you want to use your code, and define the code's interface. You're also forced to decouple things enough to make them testable. Who starts their projects by thinking about which framework or technology or database or something that they use? Yeah, hands up. So, yeah, come on, you guys are lying. Everybody thinks I'm going to use Spring, I'm going to use PHP, I'm going to use Zend, I'm going to use Symfony. Yeah? Everyone does that. So, who's ever seen a framework or technology start to take over a project? Like you can see the file structure and everything just reflects the project. Yeah? Whoops. Who has test code that connects to a real database of some sort, including SQLite, H2, or MySQL? Be proud, come on. Yes. Woo. So, around 1998, I read that book over there, and that's the first time that I ever came across the kind of idea of a layered architecture. That book kind of had this strange and alien idea to me that, firstly, the author introduces how games were written in the past on like arcade machines. And he said that on arcade machines, in order to get the maximum performance out of the arcade machine, people would actually rely on the hardware and do like tricks based on the hardware to get the maximum performance out of them. So he said, when that book came out, because we have way more memory and way more processing power, we can kind of stop doing that and start to actually make our games make more sense. So he was talking about this idea of actually creating the game world and then taking all the graphics and making those plugins of the game world. So essentially is separating your core of your game from the hardware, the graphics, any frameworks that you use, maybe the inputs of the game engine that you might use. And so around 2004, I wrote a Super Mario clone, because everybody does that at some point in their life. So when I wrote that game, I wrote it in Delphi, which may have not been the best choice, but that's what I was using at the time. And I actually wrote it in a way where the game world was separate to anything else. So the graphics were just a plugin that I added on top, and the input for the game was just a plugin that I added on top. And what that let me do, in 2005, I rewrote it, and I rewrote it in C. And instead of going to my game world files and rewriting them one by one, I downloaded a program called Pass to C, and ran my code through it. And the game world was done. It was working. I had no modifications to make. It was all working. Then I got a game engine. At the time, I was using SDL. And I made SDL use the game and draw the graphics that it needed and get the input that it needed. So I actually had the game working about a day, maybe half a day. And I didn't really have to rewrite that code, which is kind of cool. So why do we want a layered architecture? So that's the story of Prometheus. And Prometheus gave mankind fire. And for giving mankind fire, he was punished by the gods. The gods tied him to a rock, and they sent that lovely bird to extract his liver every day. And at night, his liver would grow back, and they would do it over and over and over again. So we want a layered architecture because we don't want to be tied to our frameworks. We don't want to be tied to our hardware. We don't want to have to always be bound to that thing. We don't want to be like Prometheus stuck on that rock. So a good software architecture maximizes changeability. The reason hardware is called hardware is because it's not changeable. We want software to be soft and changeable. Changeability is the whole point we have software. Decoupled software is easier to change. Good software architecture minimizes duplicate code, minimizes complexity and responsibility, organizes software around use cases, business needs, and features. So now we're going to have a look at a simple layered architecture, which is clean architecture. I love that picture, it's great. So, clean architecture has 3 rings, actually 4 rings, and you can see in the outer ring are things that are kind of like hardware. Databases, devices, the web, the UI, external interfaces. Inside the green ring, we have some software, which is your controllers, or like your frameworks, gateways that speak to databases or remote procedure calls, and presenters. We also have in the center, this is kind of like the game world that I spoke about earlier, your use cases, which are your business logic and all the features that you need to support. And in the center, the entities that make up your system. So some people know these as models, other people know these as entities. And mostly that's what the clean architecture looks like. Yeah. So something that's very important for the clean architecture is the dependency inversion principle, which tells us that we have to have low-level policies depending on high-level policies. So the way you do that is in Spring, or if you use Symfony, you define all the things that might change in some sort of dependency injection container and swap them out at runtime or in your configuration, which allows your use cases to remain intact and let you change things as you need. Another important part of the clean architecture is the interface segregation principle. So whenever you implement something like a gateway or a repository, generally I've seen when people start out that everything an application does lands up in one repository, which is bad. The reason it's bad is if you had to change that particular repository with some other implementation, maybe you're going to use a different database or API calls or something, it doesn't let you quickly change parts of the program. You have to sit and change every single method inside your huge interface. So the interface segregation principle makes us limit interfaces to just the use cases that we need. What that means is that if I have some feature for my program, I can just change that feature's repository and have the other repositories using the other database, if that's fine to do, or an API, or whatever needs to be implemented in the repository. So it stops this interface explosion, which is really, really, really a good thing. So, pros and cons of clean architecture. Good is it's use case focused. So every use case that your users might need is a separate kind of directory or module in your code. It's framework independent, testable without involving the framework and database. Frameworks and tools are easy to replace and easy to reuse and compose use cases. The bad is that it's slow to write code in this way. Some people think so, but in my experience, the speed that you get from your tests and everything being cleanly laid out, in the long run actually help you to gain speed. Some people think that you might have to do a big design up front, but in my experience that's also not true. The number one rule that I keep in mind is just don't let the core of your application, the use cases, depend on the framework or the database. I have 7 rules that I tend to keep in mind when I'm programming. First one is use test-driven development to make sure code is testable and usable and keep your tests fast. Use a layered architecture to make sure your tests are decoupled from your database framework. Every class should have a single responsibility. That's a single reason to change. Every method should have a single responsibility. This one I can be a bit more lenient on. You should keep code dry so that you don't duplicate yourself, relevant code, but not too dry. So sometimes, because everybody is trying to reduce the amount of duplicated code, I find that they do it at all levels of the application, and sometimes that's not good. Way that you can think about this is in functions, in classes, you probably don't want any duplicate code. But sometimes, maybe a microservice that does something similar but slightly different makes sense. The higher you go up in your architecture, the less sense duplicating things sometimes makes. So it's something to keep in mind. And I would recommend investigating using test doubles instead of mocks, and pick a side of a style of testing. So you can be either classicist or a mockist, and we'll go into that a bit more when I do my demo. And another very useful thing to keep in mind while you're programming, at least from my perspective, is functional programming principles, keeping variables immutable, and generally trying to keep functions idempotent so that you don't depend on state much throughout your application. And lastly, transformation priority. So transformation priority is sort of like a series of refactors that you can apply to your code that often leads to the most efficient algorithms, which is a very interesting idea, and I recommend that you look into it. So, I'm also going to borrow Uncle Bob's 3 laws for test-driven development, which are: you're not allowed to write any production code unless it is to make a failing unit test pass. You're not allowed to write any more of a unit test than is sufficient to fail, and compilation failures are failures. You're not allowed to write any more production code than is sufficient to pass the one failing unit test. By the way, Robert Martin, Uncle Bob, also created the clean architecture. So it's demo time. Yay. So, how many PHP programmers in the room? Quite a few of you. Okay, cool. So today I'm going to do this in PHP. And I'll start. So first I'm going to make a method to test that my tests are working. Test that tests are working. And let's run that. Yeah, so I can test things, which is really good. Then I am going to create a new use case. So my new use case is, let me tell you a bit about what the program is going to be. So we're going to just create a use case that's going to create a monster. So a monster is just a model that's going to have a name and an ID, and we're going to save that into a database. And it should illustrate how to create a simple use case. So I'm going to create monster use case, and we're going to create that class in our test directory, in our source directory. Okay. I'm going to keep a flat file structure for now, just to make it easier to develop, which is something I actually do in production as well. When I'm actually developing code, I like to see what the structure of the code is going to look like before actually putting it into packages. So it might be a best practice to try out as well. So this is our monster use case. Let's see if our test still works. Ooh, it doesn't. Excellent. That's the kind of thing you want in a live demo. So why is that not working? I might be forced to move this into the test folder. I know I'm missing a directory called create monster use case. And my test pass is excellent. So we're going to actually now change this test to do some functionality. So the test I'd like to write is that the ID that I put into my use case in my monster is going to be the same ID that I get back from the use case. So the way we're going to do that is check ID is same Okay, and that's our use case. I'm going to put that into a variable, and we're going to make a handle method, and that's our handle method. I made a mistake in TDD, so I wrote some production code without writing a test. So that's not good. So let's reverse that and undo that and run our test. So our test works. Now I'm going to write my assertion. So I'm going to assert equals that the ID I'm going to put in is going to be the same as the response that we get back. Okay, so how are we going to get that? Let's make a new create monster use response, and I'm going to run our tests and make them fail because our class doesn't exist. Actually, for that. And now I'm going to create this class. I'm going to make it in the source folder. There's no shortcut key for that one, unfortunately, depending on what language you're using. So that should now compile. Ooh, doesn't. Yes, so the assertion doesn't work because it doesn't return anything, which is fantastic. And I'm going to extract that out into a variable. And we're going to get back the ID. Now that's going to fail because that method doesn't exist. And we're going to add that method to the response. It's also going to fail. And first thing that we can do to get this passing is return the value 1, 2, 3, 4. And that should pass. Now, some of you might be thinking, that's a really weird test to do. That's odd production code. So usually, if you think about the transformation priority premise, you take steps into making your code deliver the thing it needs to, taking the most minimal steps that you can to do that. So I got my test to pass. And I didn't need my use case, so I actually went a bit further. Should have written the assertion first. So let's go back to our use case now. Our use case now actually has to start doing something. We have to start making this test actually work. So what we're going to do is start passing things into our use case. So first thing we're going to do is pass our response object into our use case and try and make it do something. So if we go here, let's just change the test so that we have something to show us that we're making progress or not. So in the use case, I am going to create a handle method. And instead of passing the response into the use case, I'm going to pass it into the handle and create that method. So now we're going to do something with this response. We're going to set the ID to something. And a lot of the time, people like to use setters and getters in their objects. But for use cases, I've found that your requests and your responses, they never really do anything more complicated. So sometimes it makes sense to drop setters and getters if the only thing you're going to be doing is setting and getting. Unless you have to protect something, it doesn't really make sense. So we're going to change the structure of this a little bit. And instead of having, Where's my response? Instead of having a get ID method, what we're going to do is just have a public ID. Okay, and we're going to give that a type, so that's going to be string. And let's fix our test. So the test is going to be ID, and our use case is going to be setting that ID to 1, 2, 3, 4, 5. And that doesn't pass because I got the string wrong. Excellent. So on the one side I put 1, 2, 3, 4, 5, on the other side I put 1, 2, 3, 5. So now our test passes. Okay, so now we're going to evolve this design slightly more and add a request object to our use case. So I would like the signature to be that the request is first and the response is second. So I'm going to create this monster request object, and I'm going to create that class in the source folder over here. And does it still compile? No. Excellent. It's a strange error. Because I've changed the style of the method signature. So I'm going to do create monster request, and that should compile. Yes, it does. Excellent. So now I'm actually going to get something from this request. So let's go back to our test and change it again and see that we land up with the same thing. So create monster request ID should be the ID that we allocate from there. Okay. So you'll notice that I don't actually return an object. I pass everything into the use case, and that just makes it neater because you create your objects in one place instead of creating objects elsewhere. Just makes it slightly nicer and easier, and might help you with things like batch jobs in future. So let's put this into a variable as well, just for fun. Tests will pass. No, they don't. Undefined property ID in the request object, and that's because we don't have an actual request object with an ID field yet. So we're going to add one. So I'm just going to tell PHP what kind of object we're dealing with. And now I'm going to add that property. No, not. PHP, I'm going to add that field. So let's type hint that. So that's going to be a string, and A. Thank you. That's public. Is that passing? Not yet. Is good, because I'm not actually setting it to anything in the test. So if we take our create monster request and set ID to 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6. That should run. Awesome. So that is our first test actually working. So let's add another test. Actually, that's not our first test working. So this use case doesn't really do much. You put a request in and you get a response back, but where's the database? Where's the actual storage of things? So in our next test, we're going to actually test that what goes into the database is what we put in. So let's try do that. Let's test that database ID is same as request ID. So I'm going to duplicate some code, but let's duplicate it first and then we'll clean it up a little bit later. So first thing we need to do is start creating a repository. So I'm going to create, let me just tidy up a little bit. I'm going to put my use cases up there, my request objects there. And now, for my use case, I am going to make a new create monster repository. And that class doesn't exist, so it's going to fail. So let's create that class. And let's make it in create monster use case. Okay. So that should compile now, sort of. New. Doesn't match the expected string. Make that a little bit bigger so we can see. So let's extract this into a variable called create monster repository, and let's get our monster from that and also get our ID from the monster. Okay. So this is going to fail because there's no monster. So we're going to add a method, and that method is going to return a new monster. And we're just going to tell PHP that we're doing that. Now that class doesn't work, so the test is going to fail because the class doesn't work. So let's create the class in our source directory. And a monster is going to have a ID field. And in the ID, I'm just going to have an ID, and we're going to return it with getters and setters. Okay. A lot of people like to have their objects immutable in their domain. So we could just make a constructor that sets the value of the ID, which is fine to do as long as you have fewer than 5 parameters. If you go over 5 parameters, you might want to start making static methods that actually populate the values for you. So I'm going to get rid of the setter and go back to here. Does that work? No, because there is no ID, so we're just going to make a fake ID. Okay, so the assertion fails because the IDs are different, which is fine. So let's make that pass by supplying the right ID. So that's working. And now this still doesn't do very much, so let's take it to the next step. We need to make sure that the repository is actually saved so that the monster is actually saved in the repository. So let's write a new test. So we're going to check that the ID is the same and monster is saved. The way we're going to do that is we're going to start injecting our repository into our use case and using it. So instead of using getMonster, we're going to actually turn our repository into a spy. So I'm going to change the name of this method into getLastMonster. And I'm going to add a save method inside this repository and use it in the use case. So I'm going to create a nice little monster with an ID. Create monster request dot ID, and I'm going to put that in a variable. And now we need our repository in our use case. So we're going to inject it over here. Create monster repository. And I'm going to create a constructor to accept that repository. Create monster repository. And we're going to make it of that type. And we're going to let our ID create that for us. So now it's a private field. And we can use over here. And we're going to call save. So now we've run into a problem. The save method is a real method of the create monster repository, but getLastMonster isn't really a real function that we want to have on our interface. So what we're going to do is we are going to change the name of this class to create monster repository spy. And we are going to implement it. So this is going to save a monster for us. From the supplied monster. And that looks good. So instead of returning a new monster, we're going to return the last saved monster. Let's change. So monster return there. That looks good. So we have an error somewhere. Create monster test on line 12 and defined. So what's happening is that our other tests, the signature has changed of the use case. So we need to add our repository to our other tests. So we're going to add those tests now. I should be refactoring, but it's a bit hard to remember all the steps when doing this live. So tidy that up in a bit when we get things working again. So we haven't supplied a monster to our save method, and there's no get ID on the monster. So, ooh, there is. So this is returning now, which it shouldn't be. Let's see. Can anyone spot the error? Call to a member function get ID on null.
In your tests, didn't refactor to get last ID?
Here? That seems right. Ah, good catch. Nice. Cool, so that passes. Excellent. So that is now saved, but we don't want to really depend on the create monster repository spy in our production code. So we should probably make that an interface. So let's start tidying things up a little bit. Let's go to our repository spy, and we're going to use the power of PHP Storm or IntelliJ and extract a interface. Ooh. Or not. Could also do it manually. All right. I'll do it another way. So implements create monster repository. And we're going to create that class, and it's going to be an interface. And we are going to pull members up, and we're just going to pull the save yes. So that is now an interface that we can use, and that should all still pass. We need to go to our use case and actually pass in the interface instead of the implementation. That looks all good. If you're using PHP 7, you can enforce that with create monster repository. So that still works, which is awesome. And now our tests look like a bit of a mess. So we should probably start cleaning things up a little bit. So what we can do, this repository use case, the response, the request, all kind of look the same everywhere. So what we're going to do is kind of get that bit of code to look the same everywhere. And it does, which is great. So now we're going to extract a method, and we're going to call it setup. And our IDE has detected that some other fragments could do that. Ooh, it's done something fascinating. Right, that's not what I wanted to do at all. Excellent. So I'm going to go ahead with the refactoring because it looks better. So setup method. Fortunately, The setup method is returning multiple parameters, which is great. So what we're going to do is we're going to change these into fields. I'm not going to return anything. So my ID doesn't want me to make fields, which is fantastic. Usually does. Anyhow, let's do it the old-fashioned way. And cool. So now we're going to create these fields. Okay. Create master repository. Create monster use case. Create monster. Sorry for the Java programmers who don't have to do this. Response. Create monster request. Yeah. So that's our setup method, and probably want it public. And we're going to move that up to the top. And instead of using a local variable, we're going to use that. Should have made them fields before I extracted the method, and this would have worked. But, yeah. Hopefully that will still run. Ugh. Okay. I'm gonna copy and paste.
We need to remove array from response in setup.
Array from response in setup. Okay. Ooh, awesome. That all works. And that is how you write a use case in PHP. Does anyone have any questions?
Can we do that with Java?
You can do it with Java, yes. Cool.